Welcome to this presentation of a workshop we conduct at least twice a year on Introduction to HPC. So first I'm going to share my screen. And now I'm going to start the presentation. You see at the bottom is a reference to our GitHub site, so that has companion information to this presentation, so you can look there. We also have this video on our website, so you can view it at your own leisure and pause when you want. So what we're going to do is talk about the purposes of using HPC, how it works from a user perspective, and information about actual details using Linux, and also secondly using our GUI interface, and show you how to submit a job. So if you have a workstation, say a laptop, and you're given a data set, which could be the Titanic data set, and some algorithms to predict who survives and who doesn't. So you run the algorithm, comes back, first-class passengers are likely to survive. Yay, okay, you're a data scientist. But let's say your data set is the population of California, and you're trying to predict that when the San Andreas fault lets go, who survives and who doesn't. Okay, that might be a whole lot harder. So the kind of problems that you might experience is it just takes too long to get the results back, or it's too big to fit on your laptop because the data set is so big. Or it's the kind of data set that comes with genomics, say, where you have to run lots and lots of iterations, and it just takes a very long time and a lot of effort to manage each iteration. So the solutions you might have for those, if it takes too long, get a more powerful computer, more RAM, more cores, faster, a bit of turbo boost, but that's very expensive. You could link multiple computers together if it's too big to fit on one, and that is very complicated. And if you have too many computations to run, you could use a separate computer for each job. So you might sneak into a lab late at night and hijack all of the workstations in there and spend all night running from one to the next to keep them busy and collect all the outputs. Or you can use our HPC for the same. So HPC is just a general acronym for high performance computing. It can also, you might hear cluster. So that's just another, that means the same thing, or supercomputer. Pretty much all of those are the same. And really what they are is a lot of connected nodes. You can kind of see in that image of Allocation there that a lot of the nodes all look pretty much the same as far as you can tell. And really, there are over 400 compute nodes in Allocation that are really just the same as each other. The same with Puma, except there are not as many. Puma has more powerful nodes in each one, but they're the same concept. So if your laptop is analogous to, say, a Buick Regal, which I think that is, a supercomputer is not a McLaren or a Maserati. If your laptop is like the Buick there, but the supercomputer is probably more like a field full of, they look like Dodge Magnums, which are decent cars, but those are all alike. Lots of them that are just the same, and that's kind of what our supercomputers are like. They're decent computers, they're good, but the key is that we have lots of them. So if a laptop is personal, that you use it, the supercomputer is shared, and that's one of its key attributes, is that it's busy day and night, all week, all year, just constantly runs. If your laptop is local to you, you sit in front of it, you type on it, you look at the screen. The supercomputer is remote. We have a lot of researchers who do all of their research for years, maybe, and never actually see what they're running on. The laptop's interactive, you type, get a response, but the main function of how you work on a supercomputer is called batch mode, where you submit work, you let it go, and then when the results come back, you look at the results, but you don't have to manage that process of how the compute takes place. So in a lot of our examples of workshops, we tend to use Allocation. because it tends to have better availability. It's very similar in capabilities to Pumas, just not as fast or large. But for training, it's really good. Ocelote is coming up 6 years old now, and Puma is just over a year old. So it's our newest, latest, but really you can use either. We also have Elgato, which is about 7 years old and still functions. Okay, so let's look at the logical, not the physical view of our HPC cluster and what it means for how you will use it. So first, we look at the Bastion host. What the Bastion host represents is protection to keep miscreants out. And so think of a bastion in the old terms of a fortress or a portal, like in medieval times. It just lets you in, but it doesn't really let you do anything. And see at the top there how you get to it, SSH netid at hpc.arizona.edu. We're going to go over two methods to access supercomputers. So this one is the command line, and we'll also do the GUI mode, and you'll be shown both. All right, so here's an example of what it looks like when you do what I just explained on the previous screen. So you do the SSH, then you see this information about a Bastion host, and then you type shell, and that takes you from the Bastion host to the compute node. And that Bastion host is called Gatekeeper. The other one is called Keymaster. So we have two, one is active and the other is idle, and we rotate them periodically. So you'll see that reference to Gatekeeper in the prompt, and you'll know that you're on a Bastion host and you can't really do anything except get to the compute nodes and the login node. And then further down, you'll see a prompt, and then and there it's on the left side, it says Puma. By default, you'll be taken to the Puma's environment. And if you type Ocelote, you go over to Ocelote's environment, and the prompt will change on the left side and show you that you're on Ocelote. The second mode of getting access is on a web browser. So ood.hpc.arizona.edu, and that takes you to the authentication, the same as you did on the command line. And then you can get to a GUI version. So this is more intuitive. It looks more like regular workstations, even a Linux workstation. So whichever you want to use is a preference. So over time, you might find it faster to do it by command line and more easy to keep organized. But the option is there for you, and there's really we don't have a preference over which one you should use. Okay, so you're through the Bastion host and you're on a login node. You see at the top, the prompt has changed. So now that I'm on the login node, that's where I can get a little bit of my work done. And it shows that I'm on the Puma environment. Logged in as Chris Reedy. Windletrap is the name of one of our two shells. If the other one's Genonia, if you do a Google search, you'll find there are actual real shells in the ocean with those names. It's got a timestamp, and then there's a command there, ls. The typical prompt is the $, but you can change that in your environment, so it doesn't always look the same. So the login node, you see that it connects to compute nodes and it connects to storage. So here's some of the detail here, just more reference information on the prompt and what it does. Okay, so a login node and what a login node can do. So back to our car analogy, think of it as a golf cart. It can take you a few places and it gets you around, but it doesn't do much. If you want to drive up to Flagstaff, you're not going to go in a golf cart, but you can take one of the compute nodes. They are bigger, safer, fits passengers, fits luggage, big enough fuel tank capacity to get you up there and back again. So that's more that comparison. So what you can do on a login node is you can submit files, submit jobs to the scheduler, and we'll talk about that. You can edit files in there. You can manage your files, manage how your data is organized, create directories, move things around. What you do not do is do compilation of codes, because there are, one, not enough resources there to do so. And secondly, it's not powerful enough to do that. So you will bog down other users if you try. And the other things that you do not do is testing of your codes. So you don't do your job runs there. Again, the environment is probably missing things you need, and you will just impact other users. So don't run calculations on the login node. For this next section has information about the command line access. So here's a simple command, who am I? And it shows output. And so for all of this hands-on part you're doing, note down again the GitHub. And that was the same as the reference on the very first page. Now the command you might want to use is path to working directory, PWD. You would think of this command as where am I? That would be more useful because there is a command called who am I? And so that shows where you are located currently. It's also part of the prompt. In the prompt, you see that tilde sign that's after the timestamp. And that's the same exactly as your home directory. It's just a much shorter way of typing it. Here are some other commands. Now, this is part of the practical part. So if you do ls, it shows you where you are, well, the files that are in your current directory. But then we have you make a directory. So make a directory, and you can call it whatever you want, but you can use the example here. And then you can list the files again. So you've made a directory, you look at what's in there, you'll see your directory is listed. Then what you do is you change directory into that one you just created, and you'll see your prompt is changed again. You can go back to where you were with the cd space dot dot and look at the prompt, and you see it's changed back to what it used to be. Or you can change directory instead of just relative to where you are, changing to intro to HPC, you can put the full path, which just starts at the beginning of the path. It's just another option of getting around. So you're going to be in the intro to HPC directory for the next parts. And so the next part is to copy a file from somewhere else. And in this case, the somewhere else is a directory that I own, and it's shared. So you can copy that file and note the period at the end. That means copy it to the current directory. So that's why I had you change directory into intro to HPC previously. Now you can look at what's in there, ls, and you can look at the contents of that file you copied from my directory, cat license. We have more information on working with Linux shells. This was just super brief, very introductory, just help you navigate and do some simple exercises. We have another exercise coming up on submitting a job. So you got the basic information on how to do the commands that will follow. All right, so now in our logical view of the supercomputer, let's look at the storage. So you see from the login node, there's a line directed to shared storage. So from the login node, you can access your shared storage, but from the Bastion host, you cannot. Every user, when they establish your account, gets a home directory and access to the API's group. So the home directory is your default. It's 50 gigabytes, and no, it's not backed up. When you first establish your account, it takes a little while to get through the university's identity system. So you might have to wait 10, 15, 30 minutes before you can actually use it. It takes a little while. So sometimes we get questions about, hey, I've established my account, but I can't get logged in. So time to get coffee. You'll also have access to a 500 gigabyte space that belongs to the PI who sponsored you. And so that's a space that you can use according to your group's policy on using disk space. Note also that this is not backed up. So the idea of not backed up is if you delete it, you don't get it back. If you accidentally delete something that you didn't mean to delete, send an email promptly to support or use our ServiceNow portal, and consultants can probably get it back. There is a very short time frame where we keep files for a few days. So don't delay if you think you've lost something. Once you're logged in, you can run this command, quota, and it'll show you the storage options that you have and how much is being used in each of those. Additional storage. So there's X disk. This is an area that can be requested. You can get up to 20 terabytes. And the idea is that it's project related. So you're working on a project for 6 months, let's say, or a semester. And so you want extra storage for that. And when you're done, you move the data that you need to keep to somewhere else and delete the data that you don't need. And this X disk will go away. If the following semester you have another project, you can ask for another X disk and do the same thing over again. But this is not permanent storage that would last for years. We don't have that currently. We will have tier 2, a secondary option available this year. There'll be more information coming about that. Each compute node has a temp directory, and that can be used during the job. So let me just skip back. Each of those compute nodes represented there, and Ocelote has over 400, Puma has over 200. Each one has an internal disk, and that disk has a directory called temp, and that temp space is available for use during a job. So it's important to know that when the job is done, that space is cleared and is no longer available. So it's working directory temp. And a lot of applications define a temp space and they'll use it, and that's very good and very practical. And so if you think it's data you need for the next job, you won't put it there because it'll disappear at the end of each job. Time allocation. So you get an allocation of time as well. So each PI, the PI that sponsors you, gets an allocation of standard hours. So a CPU hour is the wall time of 1 hour for one core. So Ocelote has 28 cores, Puma has 94 cores. So if you have a 28 CPU hours on Ocelote, it gets you 1 hour of a whole node. And so you get 70,000 hours total for each PI group. That's a lot. Ocelote 36,000, Elgato 7,000. And there are additional limits on using GPU nodes. And when you start a job using the standard queue, your job will not get preempted by anyone else, even if they have a higher priority than that. The other option is Windfall. Everyone can use Windfall. It's not limited in terms of how many Windfall hours you can use. It's limited by how many days you can run a job for. There's some limits there and how many hours you can use concurrently. But in a month, you can use as much as you're able to get work done. The key, though, is that it's preemptible. So when a standard job comes along and it needs space, yours might be the one that gets chopped. So the job stops and is killed. So if you are going to use it and run long-running jobs, you'll need to have a method of collecting the data as you go so you don't lose everything. So that's an option in some applications, or you can build it into your job to collect and make progress. It's called checkpointing. Right, back to our logical view. So you notice on the bottom left is a file transfer node. So the function of that is you see the connection there, that line goes to the users. So it has a, let's call it wider data pipes. So it can be much more efficient and faster for large data transfers and won't keep the rest of the resources so busy. So there are two nodes and they are called filexfer.hpc, and you might end up on one or the other. You don't care which one. And then you can run commands to copy the data, and those are some of the commands listed there. And if you see at the bottom, and marked in green, Globus, we have a subscription to the Globus service, and we recommend that for large transfers where you're doing it repeatedly. One of the advantages of Globus is that you kick off a transfer and your connection drops, it will resume and then keep going. And then when it's all finished, it'll send you an email that it's done. So you don't have to have a connection that's stable for a long time. You can kick it off and then check in the morning and see what happened. All right, so showing our web version, the GUI version of what I just showed you, you can use on demand, and you'll see once you start it in the top left, there's the files with the drop down, and it shows your home directory, shows any other file systems that you have access to. So in that case, groups is for your PI, and Xdisk is that optional one. if you have it set up. So a neat capability in there is download and upload of files. So if you just are moving a few files around, that's a fairly intuitive way to move files in and out of your directories back to your workstation. Okay, so you got to the login node, you're doing some editing and you want to submit a job. How do you run jobs on the cluster? There are hundreds of nodes. How do you manage them? So these are the sort of questions. Are there jobs? Are there nodes available? What kind of nodes? What gets run? How do you know you get in the queue? Where's your place in the queue? So the scheduler manages all of that. That's how we have Puma 95% busy all of the time, because the scheduler is taking in work, creating queues and sequencing, finding resources, creating space, submitting jobs, ending jobs, starting the next one. That whole very intricate process is all handled automatically. So what it does, it takes in the request for resources, puts the job in the queue, waits for resources to be available, assigns a job, assigns the job to a node, runs the calculations, and then when the job finishes, it sends in output files, and it frees up the node for the next person to use it. It also has a neat capability of running multiple jobs on single nodes. So Puma has 94 cores available. If you want to use 20, that's fine. Someone else can use 20. Someone else can use 30. Now we're up to 70 and there's still 24 left. So there might be single core jobs and they'll fit in the remaining 24 cores. So multiple jobs are running on single compute nodes when there's resources available. So it's a very efficient way of using up what are really very capable computers. All right, so just a reference here, all of the clusters use Slurm. Last year, we reconfigured and rebuilt them so that all three use Slurm and they all use the same setup. And so you just use a simple environment command of the host name of the cluster name to switch from one to the other. So by default, you end up on Puma and you just type Ocelote and it flips you over to the environment on Ocelote. So we have it pretty well coordinated. All right, here's the next practical part and the last practical part, and that is how to submit a job. So what you're going to do is copy a file like previously from one of my directories, and it's called sample slurm script. And remember the dot at the end, space and a dot. And that means copy it to where I am now. And where I am now is the intro to HPC directory that you created. So then take a look at that directory. Take a look at the file that you just copied over. And let's break it down. The first part of it identifies it as a bash shell script. Bash is the shell that we use. If you, by your previous practices, use a different shell like C shell, T shell, so those can be problematic. So we really want you to use bash as your shell environment. All right, the next part is the Slurm directives. So you have to have a job name. You just call it test. We identify where we want our error files, -E and -O output files to go to. And they'll be called test dot and then E and then the name of the number, numeric identifier of the job. And then we say where we want it to run. Partition is like queue. So we're going to send it to the windfall queue. Remember that's unlimited, but it can be preempted. We are going to ask for one node and we're going to ask for one task. A task is synonymous with a CPU or core. All of those three terms really mean the same. Node means run it on one compute node. Well, if you're only asking for one core, it is only going to run on one compute node. But if you ask for 2 cores, it's possible that your job would split and run 1 core on one node and 1 core on another node. And that's all very well, except that your job, if it needed, say, 10 gigabytes of memory, it would only use the memory in the first core on the first node and you get problems. So by default, just put in nodes equals 1. And if you need more than one node, you're going to be using MPI because that's how we do multiple node activity. So nodes equals 1 is a good default. And then the last section is, this is the commands you're actually going to run. So if you're on your laptop, you could type in these. And this is your job, effectively, in this example here. It's a very simple one. All right, so now that we have the script, so you do sbatch to submit it, and then the name of it. And remember that you're on the login node, which has shell names when you do this. If it works, you will see that it submitted it and it gave it a numeric identifier. So in this case, it's the 2,118,950th job to run on Puma. You can use SQ command to look at the job. And in this case, under the last column, it should list the node name that it's running on. And it doesn't put that, it's got priority because it means it's waiting in the queue for priority to come to the top and start running. So priority means it's waiting. When it's finished, you can look at the test.o and then the job number, because you know what that number is because it told you what it was going to assign it. And you know the job, the name of the file is going to be test.o because that's what you put in your script. You were going to call it test.o and then the number. And then it comes back and says, the script is running on, and then the host name, which is what you asked it to do. And then it'll also tell you that there is data available about performance. This is one way to do it, and I'll show you another way of how to get detailed information about the job that you ran. All right, so let's change the script and use 4 cores instead of 1. So use your favorite editor, VI, Emacs, and then look at the options, how to change it, and then run it again. Sbatch, now you'll get a new job with a new number, and you can look at it and see what changed. And then here's another option, change the script to use standard instead of windfall, because remember windfall can be preempted, and if you have permission from your PI to use the standard queue, then the options there show you how to change the script to run on the standard queue. All right, so a couple of commands that are useful. SQ to look at your job and its status, and you can use the pipe symbol to sort and reduce the number of outputs that you get. Scancel to end a job. Scontrol to look at a running job, which is quite useful. You can look at the resources it needs, where the directories are, and what it's doing. And then this one, SIF, is really good for details about a completed job. So this was the reference that I just made a minute ago about another way to look at what your job has done. When you get started and you are getting going, you will typically create a workflow of how you bring your data in, where you organize your data, what kind of jobs you're running on it, how long the jobs run for. This information will tell you whether you have matched up the resources you asked for well against the resources that the job needed. So let's say you asked for 2 hours in your job to run it, and you look at your output and there's an error there that says you ran out of time and the job ended abnormally, and that's why you don't have the results you thought you would need. So you clearly need more time. So bump it up to 20 hours. So you run it again, and at the completion, and here it'll show you that it completed in 5 hours. So now you know you don't need to ask for 20. 5 will be pushing it a little, so you might ask for 8. So this lets you play around with that resource of time, and it can let you play around with memory. You asked for 10 gigabytes of RAM, which would typically mean you need 2 cores to accomplish that. And it said it only needed 3, so maybe you can fit it in 1 core. So you're working with the resources you need and the resources available for your job. A couple of other commands that are useful when you log in and you want to see what's going on and you're wondering why your job hasn't started yet. You can see how busy the system is with these 2 commands, nodes busy and system busy. All right, so that was the batch approach, and here's the interactive approach. The difference is batch is you submit a script, it asks for the resources, it assigns it to a compute node, and it goes away and does its thing and comes back and gives you the output files and the files in the directories that you wanted it to create and fill. Interactive is when you want to go onto a compute node and maybe do some testing, you want to compile, you want to run some work from there and get responses back pretty quickly to know if you're doing the right thing. And that's where all of our software modules are, and I'll talk about software modules presently. So this command interactive, and it will give you that session on a compute node. And see at the bottom there, the prompt changes to include the name of the compute node. You don't need to know what those numbers mean, but R3, 13, and 1 represents one of the many, many compute nodes on Puma. Interactive is an alias, so it's a command that represents, but the actual command that runs is that long one right there. So that's kind of a minimum needed to get something done. If you think that WinFall is too slow, it's taking a long time to get it back, but you can use standard, and you want to use standard because it will be faster returning, but you'll only be using a very small resource. So out of the 70,000 available hours, you'll only be using a handful of those for your work. So you can just edit to change that. And there is some interactive help with that to change the defaults from the alias of interactive. All right, so this is the on-demand GUI version of what we were looking at. So you'll go to jobs and then choose job composer, and then, or you can use active jobs to look at the jobs you have running. So this is a similar outcome and just a different way of doing it. All right, I mentioned software modules. We have over 100 different software packages installed as modules. So if you want to use MATLAB or Python or any of the other 100, this is the best way to do it. So the main point to mention here is they're not available on the login nodes, which used to be in the past over a year or more back. They are all on the compute nodes. So you can look at the list either in our documentation, or you can go to the shell, then go over to Allocation. Remember, it's a little quicker, type interactive, and then when it puts you on a compute node, do module avail, and you'll see all of them. So now the GUI version of doing that is you can access them using on demand. And so a couple of the common ones, ANSYS, MATLAB, they're available. You just choose those resources right there on those tiles, or up on the top screen, interactive apps, you can go to the desktop. So this applies to running modules that have a GUI interface. See how they all have Abacus GUI, ANSYS GUI, Mathematica GUI. And once you select the resources you need, resources being how long you want it to run for, how much memory, CPUs you need, and it's ready to go, it'll show you the screen like this. And up top in the blue square rectangle, it's got the host name, it's running on Allocation, and then at the bottom blue rectangle, it's got launch MATLAB GUI. So you click on that, it'll start, and it'll look something like this, which is very workstation looking. All right, so then the equivalent over on using the command line. So back to Allocation, interactive, we do module avail, just demonstrated in the 2 slides back. Then if you want to narrow down a little, because there's way too many to look at, say you want to check what Python is available. So module avail Python, you see there's 3.6 and 3.8 currently. So module load Python 3.8, and then you start it with Python 3. And then in this example, we just import a package, NumPy, and then quit. So what the module environment does, it sets your paths. If you just do, excuse me, echo path, it'll show you the commands, it'll show you where commands run from without having to ask specifically for the path where they are. It also sets your libraries, the path. So you can type that command to look at the default libraries that you use. So a lot of applications need libraries, and you shouldn't have to know where the libraries are located. So here's an example. If you type which free surfer, it should not find it. But then if you module load free surfer, it'll now set the environment, and you type which free surfer again, you'll see that there's information about that package called free surfer, and it's executable, also called free surfer. So try those two echo commands again. You'll see that the environment has changed for the path and for the libraries. Here's a reference page of some more commands to use with modules. I'm not going to go over them. You can look at that in your own time. All right, the last thing that I have is information on getting help. So you can open a support ticket. All of this is included in our documentation. There are multiple references in there to open a support ticket using ServiceNow. We have office hours on Wednesday afternoons, and so there's a link to that, also referenced in our documentation. You can also send emails for support. That's perfectly fine as well currently. And there are the list for the emails for HPC consult, for visualization, and for statistics. And the last thing I want to mention is these two community events that are held weekly. And so the Coffee and Code and Hacky Hour, those are referenced there. Thank you for your time, and feel free to ask us anytime if you have questions about how to use our HPC resources. We're here to help, and we are always want to make sure that you get as much usage out of the systems to get your science done.